Hi guys, in today's video we'll continue off with the trunk port as I've elaborated on my previous video that today in today's session we'll look down into the trunk port. So let's look into the trunk port. So what do you understand by the trunk port? So a trunk port is a switch port that carries traffic for multiple VLANs. What do they mean by that? So let's go back to our previous slide. So a switch port is any port that you find within a VLAN. So they say it's a trunk port is a switch port that carries traffic for multiple VLANs. So we can assign maybe one switch port that can contain multiple VLANs. So I will repeat that. We can assign one switch port that could carry multiple VLANs. So that's a switch port. Also, we can use the trunk port. Sorry, that's a trunk port. So we can use the trunk port to reduce the amount of switch ports required for the topology. We can use the trunk port to reduce the number of switch port. It makes sense. So now let's say maybe for instance within our switch we've got about 5 VLANs. We can utilize one trunk port to utilize multiple VLANs. It makes sense. Also, the trunk port, this enables us to leave more ports available to add host to the network in the future. So just imagine if we had about 10 VLANs and we've got about 24 port switch. So having to cluster our VLANs accordingly, maybe we'd say each VLAN would contain maybe 5 switches, because now since we've got 24 ports, so the trunk port gives us that functionality, that flexibility to have one switch port. Within that will carry out multiple VLANs. We have in this instance about, we've got VLAN 10, VLAN 20, VLAN 40, we've got VLAN 40 and 50. So those would be our VLANs within this network or this environment. So in this instance, we can just have one switch port that could contain, this 5 or multiple VLANs. So the physical topology operates, it's the next slide that they demonstrate. So this physical topology operates, but it requires far fewer switch ports. So we were able to use a total of 4 trunk ports across both switches to replace 8 different access points. So access point, remember, it's your switch port. So in this instance, we were able to use the demonstrations. We're able to use a total of about 4 trunk ports across both switches to replace about 8 different. So at least we've managed to save 4 trunks. So if you can see on the next slide, these are the trunk ports that are being used. So we've got about 8. They said they use total about 4 ports. Let's highlight this. 4 trunk ports across both switches. As you can see, you've got like about 1 2 I've got 1 2 3 4. No, this is your access. These are your switch port. Your trunk, you've got 1 2 3. So also the switch ports connected to the end host devices are configured as access points. That means you've got your workstations, printers, and servers. So those are referred to as access point. So if there is anything that is being connected to, which has your servers, your printers, and your workstations, we refer to those ports being as access points. That is important. And also switch ports which are connected to other network devices are configured as trunk ports. You've got switches and routers. So if we have switch ports which are connected, your switches and routers, those are configured as trunk ports. So if you can see on this slide, because of we've got the switches connected to, in this instance, why we've got 3, not 4, as initially explained on this slide, to say you've got total about 4 trunk ports across both switches. So in this instance, because of now, remember, these access points or these switch ports where we connect our switches and routers. That's where we configure those switch port as trunk ports. So now we've got about 3 ports being utilized. So we've got this port which is connected to this router, and this port which is connected to this router, and this switch which is connected, this port which is connected to the above switch. And also we've got access port, which we in this instance we have our end devices like your desktop, servers and printers. So these are configured as trunk, and these are configured as access ports. Also, on slide 90, a trunk port on a switch can receive traffic for more than one VLAN. So a trunk port can receive data. Let's highlight that. Can receive traffic for more than one VLAN. It's very important. So now a trunk port on a switch, let's highlight that. A trunk port on a switch can receive traffic for more than one VLAN. So for example, the link between the two switches is carrying traffic for both V10 and VLAN 10 and VLAN 30. So the two switches is carrying traffic for both VLAN 10 and VLAN 20. So VLAN 10 and VLAN 10 and VLAN 30. So it's both carrying traffic for VLAN 10 and VLAN 30. So in both cases, the traffic is leaving one switch as a series of ones and zeros, and arriving on another switch as a series of ones and zeros. So the next question will be, how will the receiving switch determine which ones and which zeros belong to VLAN 10 and which ones and zeros belong to VLAN 30? So whenever a switch is forwarding a traffic out a trunk port, it adds to that traffic a tag. To indicate to the other end that what VLAN that traffic belongs to. So this allows the receiving traffic to read the VLAN tag in order to determine what VLAN the incoming traffic should be associated to. Remember, on each trunk it can contain multiple VLANs. So how would a switch determine that which traffic belongs to which VLAN? So it contains a tag. So if maybe into this certain switch there is incoming traffic to the certain port, it will determine that this tag belongs to VLAN 10 or this tag belongs to VLAN 30. So there is a demonstration which I have on one of okay, it has this is the demonstration of how the tag works. So this is a trunk port. It determines, so this belongs to VLAN 30, and coming traffic goes, so which traffic goes to VLAN for instance VLAN 30. So in this instance, it's just a demonstration of how this incoming traffic goes. So PC7 would send traffic, and the trunk will allow the traffic because if it contains numerous VLANs, so it will allow the traffic to go and send it to the correct destination. So this is how this works in terms of the VLAN. So as you can see, the demonstration on this image, how it contains tags within it, so it would know which VLAN it belongs to. So let's go back to our slides. Since we were here, so it adds a tag to indicate to the other end what VLAN and that traffic belongs to. And also it allows the receiving switch to read the VLAN tag in order to determine what the VLAN the incoming traffic should be associated to. So on to the last slide. So if we have an access port, as I've said, an access port contains or is being configured as your end devices, like your PCs, your printers, and your server. So an access port can only ever carry or receive traffic for a single VLAN. So it can only carry out a single VLAN, not multiple. It doesn't have the functionality of a trunk port. So an access port can only receive or carry a single VLAN. Let's highlight that. So therefore, there is no need to add a VLAN tag to traffic leaving an access port. I think that is being in demonstration on the next, uh, where it's just a demonstration. It's just your easy way. These are your access port. So according to the VLANs, it will just go to where you have to send that, the traffic goes to that designated PC on the network. So also I just wanted us to go back to our project, and there are certain things that I wanted us to look out for in terms of configuring the VLAN. So there are so many things that we need to in this instance that we need to do. So in this instance, on our network, what we don't have is that we're only using the default VLAN. So we need to create about 3 VLANs. So we'll name them VLAN 10 for data, ne? And we'll have VLAN 20 for voice, and also we'll have VLAN, we'll name it VLAN 30 for unused ports, ne? So this will be unused ports. So these will be the 3 exercises that we need to do on each on our switches. Remember that we have learned in terms of the VLAN for access ports, and we also have for trunk ports. That's where we need to create trunk ports. So in this instance, remember, a trunk port will assign one port where multiple VLANs would be used. Remember, so our access port in this instance will have our data, our data our end devices, let me just put it that way, our end devices. So in this instance we have our PCs, let's do this, PCs, laptops, servers, and printers. So this is where we would need, let's highlight this, let's just put it in brackets, and in this instance we want to use our switches and our routers. So these would be the trunk ports. So in this instance, this is the exercise that we'll be doing for for our network to function. So We need to create about 3 VLANs, and in this 3 VLANs we need to create VLAN 10 for data, VLAN 20 for voice, and VLAN 30 for unused ports. And also within our VLANs we have our access port where we have our end devices like your PCs, laptops, servers, and printers. And we need to also have our trunk ports where we'll have one port where multiple VLANs will be used, where our switches and routers will be in function, where we know that our data, for instance, since now we are communicating to these network, certain things would change. So let's save this, name it as, let's name this as technical support project. Perfect. So we've saved this, we are good to go. So let's get into the first exercise. Okay guys, what I need you guys to do, let's first test on our first switch. What we need to do, we need to erase everything. So let's do erase, do right erase, do right erase. Okay, and reload. Okay, perfect. So now we managed to erase everything and reload everything. We're starting from scratch. We have to create this exercise. What we need to do is we need to create about 3 VLANs: VLAN 10 for data, VLAN 20 for voice, and VLAN 30 for unused ports. So the first exercise would be create VLAN 10, 20, and 30. Okay, now what we need to do is, let's go to enable. So now we're in the switch, config t. What we need to do also is create VLAN 10. Let's see. Okay, VLAN 10, VLAN 10, and then we need to name it. We need to name it data, and VLAN 20. We need to name it voice. Name voice, and we have an identical. I think we have that. So let's name it. Okay. So name. Okay, we'll utilize, since we have created VLAN 2. We'll utilize VLAN 2 for voice. So now for VLAN 20, for VLAN 20, we'll name it unused ports. Okay, we'll name it unused P. So perfect. So what we need to do now is check in terms of the, let's check show VLAN. Okay, I think we need to oh no. Let's check. Perfect. So let's check. So we've got VLAN 2 for voice, VLAN 10 for data, and VLAN 20 for unused pod. So these are active. So that's the first step that we had to do. We created the three VLANs. We've got VLAN 2 for voice, VLAN 10 for data, and VLAN 20 for unused. If in your switch you have managed to have you don't have a VLAN 2, you can use VLAN 20 as I've illustrated on the notepad. You need to create for me instance, I've already created the voice one, which is it gives me default to say VLAN 2 is existing for voice. So create these, and the next step is to assign the ports to these VLANs. So that's the next step. Okay, so now let's get back onto our switch. Config T. Okay, config T. No man, sorry man. Config T. Yes, perfect. So now what we need to do now is configure our switch. So we have what we have in terms of the switches. So now, as we have created our VLANs, so now we need to move on to another step. Let's initialize. Remember that we have within this port, we've got this port is assigned from gigabit to fast Ethernet 01, fast Ethernet 00. I think it's fast Ethernet 00. This is the port that is assigned from the switch to the router. So we need to utilize that. So how would we know? Let's go to our physical, which we've got about is it physical? It's config. Where is our not VLAN database? Okay, settings. Let's go to settings. Switch. No. I'll go VLAN. Okay, this is okay. Let's do this. I just want to check something. On to the config. Oh, it's being which this was okay. This is external and this is internal. Yeah, so it's 80.1, which it's 0.0. Yep, it's 0.0. So now let's exit. So it's int, so it will be int, fa 0/0. Okay, and we have to move on to the switch pod mode. Yes, now it makes sense now why you're utilizing instead of using 0.0, because of 0.0 it's internal, and 0.1 it's it's external, which is the external IP address that we use to communicate with the rest of the rest of the switches. Okay, so now what we need to do, we need to say switch port mode trunk. Remember, trunk. So this port will be utilized for multiple VLANs that we have within our our network. So we've got about 3 VLANs that we have. So switch port mode. Okay, I think switch port mode. Okay, switch port mode. It's up, and also you need to set up the switch port native. Okay, so we have what we call switch port mode native. So before I even enter this and specify. So let's go back onto the slide just to explain what is the native. So we have a native VLAN. So the native VLAN is the answer to how a switch processes traffic it receives on a trunk port which does not contain a VLAN tag. Remember when we on the previous slide when I went through in terms of the trunk port, in terms of determining let's say for multiple multiple VLANs, it can reference to say which traffic belongs to by the tags. So for instance, with the native VLAN, it processes traffic it receives on a trunk port which does not contain a VLAN. So if this happens where it doesn't contain a tag, the native can process it within the trunk port. So we also have to configure that also onto the switch. So without the tag, the switch will not know what VLAN the traffic belongs to. So therefore, the switch associated the untagged traffic with what is configured as the native VLAN. So the native VLAN is the VLAN that any receives untagged traffic gets assigned to on a trunk port. I'll repeat this. A native VLAN is the VLAN that any receives untagged traffic gets assigned to on a trunk port. So any traffic the switch forwards out a trunk port that is associated with the native VLAN is forwarded without a VLAN tag. And also the native VLAN can be configured on any trunk port, hence why we have this. Let's close this. Hence why we actually configuring it under the switch port mode trunk. Should make sense now. And also if the native VLAN is not explicitly designed on a trunk port, the default configuration of the VLAN 1 is used. So in this instance, when we will configure it, we will assign it to the specific VLAN, which if any other trunk port, remember, any other trunk port for data that will be utilized will be using that native VLAN. Also, there's an illustration in terms of how the native VLAN works. So in this instance, we have a switch X and a switch Y. So these are configured via a trunk. And also we've got the VLAN 22 and the native VLAN 33. So these are your switch ports. So let's go on to the last slide. So above we have about 4 hosts. We've got A, B, C, and D. We've got 4 hosts, A, B, C, and D, and all connected to access ports in the VLAN 22 or VLAN 33. They're all connected to VLAN 22 or VLAN 33. And switch X and switch Y connected to each other with a trunk port. So host A is attempting to send a frame to host C. So host A is attempting to send a packet to host C. And when it arrives on the switch X associated the traffic with VLAN 22. So when the frame is forwarded out to switch X trunk port, no tag is added since the native VLAN for the trunk port on the switch is also VLAN 22. So but when the frame arrives on switch Y without a tag, switch Y has no way of knowing the traffic should belong to VLAN 22. All it can do is associate the untagged traffic with the switch X trunk port, which has been configured as the native VLAN, which in this case is VLAN 33. Let me repeat that. So now, since now host A is attempting to send a packet or a frame to host C, when it arrives on the switch, which is switch X, remember this attempts to send a packet to C. So when it arrives to switch X, remember the traffic is configured or is associated with VLAN 22. So it's in VLAN 22. These PCs A is in VLAN 22. And now when the frame is forwarded on switch X, the switch X trunk port, so no tag, so it discovered that this, it has no tag, it doesn't know where it belongs or where it goes to. So so when it's forward to, no tag is added, since the native VLAN for the trunk port on switch X is also VLAN 22. So when the frame arrives on the switch Y without a tag, switch Y has no way of knowing the traffic should belong to VLAN 22. All it can do is associate the untagged traffic with what switch Y's trunk port has configured as the native VLAN. So in this case, it is VLAN 33. So that's how the logic in terms of how these switches operate. So now we have a clue in terms of the native VLAN. So what we need to do, we need to go back onto our switch, and since now we want to assign the switch port native, we need to allocate it to the certain VLAN. So now remember that since we have the VLANs, for instance, the VLANs that we have created, we've got also we have, let's check, we have VLAN 10, VLAN 20, and VLAN 30. So we'll associate this native to, so what we need to do, we need to create another VLAN. We need to create VLAN 40 for native. So let's create that. So name it VLAN 40. So Control S. So what we need to do from here, we need to actually exit, and VLAN 40 name native, and exit. Then what we can do is switch port mode native, let's switch port, okay, sorry, switch port not mode, it's switch port native VLAN 40. Okay, I think there's something wrong that I've done. Let's do this, let's try with switch port mode trunk. Okay, what we need to do is int fa0/1 and switch port trunk and switch port native VLAN. Perfect, we have done that, and those are the first steps. So I would like you guys to come up until here, then we will elaborate further on the next video. But no, let me just do other few steps so that we can end up on certain things. Let me just quickly complete the other steps that we need to create on in terms of our notepad. So yep, okay, so also what we need to do, we need to create, remember, we need to assign for data which ports are we utilizing. So now what we will do, we'll say exit So we'll utilize int range. From which ports are we utilizing? So for instance, we will utilize from fa0 fa0 4 to 10, and port switch port mode access. Remember, access is for our data. So which access did we use? So switch port access VLAN. Which VLAN did we assign to for data? We assign it to 10. Okay, so this is what you need to do. So then afterwards, what is next? So let's go back into our where's our notepad. So now we need to assign for voice. So let's go back. So we need to utilize switch port voice, switch port voice. It has VLAN 2. Okay, and that's it. So now we know, now the switch understands now to say from switch port access VLAN 10, that's for data, and switch port voice VLAN 2, which is for voice. So we have done with the first exercise. We've completed. So what we can do, do memory, to write memory, to write memory to save our configs. So now we manage to save that. And okay, so that's it in terms of today's session. Please go through the exercises that I've done with you, and also just on your side, just prepare a notepad so that you can understand what have you done. So also this will explain much better in terms of what are the access port, your trunk port, your native port, and so forth. So that's it in terms of today's session. I will continue with you in the next video. Thank you.